The question is, find the equation of the plane containing the points P, 1, 1, minus 1, Q, 3, 2, minus 6, and R, minus 1, 0, minus 2. Well, there are a few ways I could find this out. I could let the equation be something like AX plus BY plus CZ equals 0. Well, maybe not D 0, but D. And that's a perfectly good equation for a plane, and I could sub in the points P, Q, and R, and that will give me three equations from which I can find out A, B, C, and D. Another way would be to kind of do it using a parametric form. So I could say that this was the point P, 1, 1, minus 1, and this was the point Q, 3, 2, minus 6, and this was a point R, minus 1, 0, minus 2. And then every point in this plane would be P plus some multiple of this vector plus some multiple of this vector, a lot like the parametric form of the equation of a line. And so that would be like P plus T of something plus S of something else. And then what I could do is I could try and cancel out the T and the S to give me my equation involving just X, Y, and Z. That's another way. But the quickest way, since both of those actually take quite a while, is to use the cross product, which is in fact designed to do all of those things in one go. And I need to use these two vectors that I've drawn. I could also use RQ and RP. As long as I do the two vectors coming from the same point, I should be fine. So let's figure out what those two vectors are. PR would be R minus P. So we'd get this like that. So we get minus 1, which would be minus 2, 0, minus 1, which would be minus 1, minus 2, minus 1, which would be minus 2 plus 1, which is minus 1. PQ, PQ would be Q minus P, which would be 3 minus 1, which is 2, 2 minus 1, which is 1, minus 6 minus minus 1, which would be minus 5. And then their cross product, PR cross PQ, would be equal to IJK, and PR is minus 2, minus 1, minus 1, and PQ is 2, 1, minus 5. So that would be I times minus 1 times minus 5 is 5, 1 times minus 1 is minus 1, minus J times minus 2 times minus 5 is 10, minus 2 times minus 1, which is minus 2, plus K times minus 2 times 1 is minus 2, minus 2 times minus 1 is minus 2, so I would get 6I minus 12J plus 0K. So therefore my cross product PR cross PQ is equal to 6 minus 12, 0. Now the cross product is designed to give you handily the coefficients in your equation. So A is 6, B is minus 12, and C is 0. That's what the cross product does. It's one of the things that the cross product does. And the reason is this: that cross product there is perpendicular to both the vectors PR and PQ, which means it has to be perpendicular to every vector in the plane. So if I put another vector from P to some other point in there, it would be perpendicular to 6 minus 12, 0. So if I stick any point in my plane into an equation that's got 6, minus 12, and 0 for A, B, and C, because my point is x, y, z, that's the dot product, so that dot product should come out to 0. So that's why it gives me the equation of the plane. So my equation is six x minus 12y plus 0z equals d, for some d, I don't know what that is yet. 6x minus 12y equals d. Now I can find d by subbing in one of my points. So one of my points is p, which is 1, 1, minus 1. So 6 times 1 minus 12 times 1 equals d. So minus 6 equals d. Therefore, the equation is 6x minus 12y equals minus 6. Looks like I can divide everything by 6 there. 6 minus 2y equals minus 1. And that's the end. Oops, and these equal signs didn't come out properly, so I'll draw them in. Alright.